Hi everyone, let me welcome you to the third session on EST 102 C programming. In this video we see more simple program in with more simple programs with C. In the last session we saw basic IO operations. So today's session is organized in your learning outcomes. Then we will write a C program to compute the area of a circle. Then we will do another program for conversion of temperature, that is from the Celsius to the Fahrenheit scale. Then we will see a program to swap two numbers. Then the summary of understanding. So what you will learn, or you will understand the C code to compute the area of a circle given its radius. Then you will understand the C code to convert temperature in Fahrenheit to Celsius. Then you will understand the C code to swap two numbers. Now the area of a circle is computed with the formula area is pi r square, where r is a radius. So this, let us look into this code. This program reads in the radius and returns the area. Okay, so essentially it uses a printf and scanf functions, and of course some arithmetical computation. So first line, it starts with hash include stdio.h. What is it doing? It is including the system header stdio.h from user/include. Then the main code is written here, void mains main without any argument. Then the statements under main are put within these braces as an independent block. Now I have two things here, the area and the radius. So the radius I am reading in, and I have to type out the area outside. So they are declared as floating numbers, float a comma r entered by a semicolon. Then I have to prompt the user to key in the radius. So I have to use this printf function, printf enter the value of radius \n entered by a semicolon. So the user will see this message displayed on the terminal. So he will key in the radius. That is read with the scanf. That value of radius is read with the scanf. It is a %f shows that this radius is read as this radius value is read as a floating number, and ampersand is kind of a pointer. It gives an idea about the address of the location where r is stored. And now this area is 3.14199 into r. This multiplication is realized with this asterisk mark. This statement is also entered by a semicolon. Then I have to print this a value to the terminal. So I say printf, the area of the circle is whatever is coming here, a as a variable should appear here. So I put a %f here, %f \n a. So the message will be, if the value of a is 10, the message displayed will be the area of the circle is 10, ended by a semicolon, and then there is the ending brace. So we will demonstrate this code here. So this is a code. So the first line is hash include stdio.h void main. So this is the same code we have seen. I don't need this line. This line is commented. Okay, I'll remove the line. So I will run this code, this area circ.c. I will close this terminal. I'll go back here. I will open a terminal here, and I will zoom a little. So I will run. So if I type gcc here, I can see my code here, area circ.c is here. So I run this with area gcc area circ.c -o a.out. So here a dot out, an executable a dot out is written. I will run this executable by dot slash a dot out. So I can enter the radius here. I will say 34, say 32.145, something like that. Now it returns the value as here. That is, area of the circle is 3246.210938. That is how the area is computed. So the last here I have put the area of the circle is percent f by ampersand a. So a will be 3246.210938. That appears here. So this is how I read in the radius and compute the area. Now let us come to another small program. So it's a program for conversion of temperature. So I want to suppose I have a temperature in Fahrenheit. I have to convert to the Celsius scale. So I use a formula C equal to F minus 32 into 5 by 9. So what I did is I have to read in the temperature in Fahrenheit, apply this formula, get a value in Celsius, and output that value. Here the thing happens is hash include stdio.h, self same line, void main, braces, float f and c, though your variables are f and c, and float fc. Then I have to prompt the user to key in the Fahrenheit value, that is printf enter the temperature in Fahrenheit. Then I scanf percent f ampersand f, that means f is read as a floating point number. Then I apply the formula C equal to f minus 32 into 5 by 9. This multiplication is done by asterisk sign, and this division is done by a slash. Then C is computed. Now I have to print of this temperature in degrees Celsius is percent f C. So whatever is computed as a floating value C will appear here. Let's run this code. This f2c.c. Here I have the self same code. Now let us run f2c.c. So I go here, I type gcc f2c.c minus o a dot out. I use the self same value a dot out. This will overwrite my previous a dot out. So here I have dot slash a dot out. So it asks for the temperature in Fahrenheit. So I say 32. So the temperature in degrees Celsius will be 0.000. Or if I run it again, it asks for 64. It will have 17.7 degree. Now if I make this some 2.2f or say 3.2f, it will print with a 2-digit precision. I say 64. Now you can see that it is printing with a 2-digit precision, 17.78, because I have made it a 3.2f. Now let us go back to my speech. See, I want to swap two numbers. Suppose I want to swap two numbers. First the program will read two values. They are stored in two memory locations, yes, A and B. Now I want the value of B to appear in A and the value of in A to appear in B. Okay, this is a picture. I have to read in two numbers A and B, two values A and B, and they are stored in the locations whose names are A and B. They are the variables A and B. Now I want to swap these values, like whatever is in B should appear in A and whatever is in A should appear in B. So one method I can use is I can use a temporary variable in between. I hold move A to temp, and whatever value is in temp to B, that way. I will tell you. This program, I use a temporary variable, like I have hash include stdio.h, void main, and the code. So these values are, I use a third value called temp. They all are declared as floating variables, float a comma b comma temp. Then I say printf enter the first number, that is read. The number A is read with this statement, these two statements, percent f ampersand A. Now I have to read the second number, enter the second number B, so that is scanf is. Now what I can do is, now A and B are in place in the memory location. Now what I do is, I make temp is equal to A and A is equal to B and B is equal to temp. So whatever value is there in A, that is put in temp, and whatever is in A, that is kept in B, and whatever is there in temp, it is moved to B. Okay, so the value of A and B are swapped. So the new values are written here. The new value A will be A and new value of B will be %f B. Now we will run this code and appreciate that. Here this is my code. So whatever value is in A, that is placed in temp, and whatever value is B is placed in A, and now all the value A that is held in temp is moved to B. I will run this code. I will clear this. So run .c. Oh, not run, I'm sorry. That is in Python code. GCC minus GCC swap .c minus o a dot out. Okay, so I will run this a dot out. Now it asks for the first number. I say 3.4, and the other is 5.6. Okay. Now earlier, initially number A is given as 3.4 and the number B is given as 5.6. After swapping, the program has performed the swapping. Now the new value of A is 5.6. So whatever was in B, that is now in A, and whatever the 3.4 in A, now that is in B. So this is how the program runs. Now I can do the swapping algebraically also without any temporary variable. So that is done by this code. Like I have this hash include stdio.h, then void main, everything else is the same. I have the floating values A and B. I don't need a temp variable. Here I use printf, enter the first number A, the scanf that reads the first number. Then this printf gives a second prompt, this scanf reads the second number. Now I can use this algebraic manipulation for this, like A is equal to A minus B and B is equal to A plus B. Okay, so B becomes my A. Now A becomes B, A is B minus A. Look at these equations. A is equal to A minus B. So A now becomes A minus B and B is equal to A plus B. So earlier it was A minus B, that when added with plus B it becomes A. So B becomes A. Okay. Now A is equal to B minus A, like so this becomes B minus A plus B minus A. So this B is now A plus B. Now minus A becomes a B. So B becomes A and A becomes B. Okay. Now the new values are printed. I can run this code here. Algebraic swapping. This is how it is done. So first the numbers A and B are read. A is now A minus B. Okay. B is A plus B. A is now A minus B. A minus B plus B will make this A. B becomes A. Now B is equal to A. Now this is A plus B minus A will give you B. A is equal to B. So I will run this code. I will clear this. GCC swap alg.c minus o a dot out. So I can run a dot out. Enter the first number. I say 3.45. I say 6.78. Now the earlier A was 3.45 and B is 6.78. Now A becomes 6.78. After swapping algebraically, A becomes 6.78 and B becomes 4.35. Okay, this is how I do swapping without any temporary variable in between. I use a couple of equations. Now, coming to the end, you understood the C code to compute the area of a circle given its radius. Then you understood the C code to convert a temperature in Fahrenheit to degrees Celsius. Then you understood the C code to swap two numbers, a with the temporary variable and without any temporary variable. And that is the end of this presentation. I thank you all.